Okay, now let's go on to question 2. So question 2 is it has many details inside here in the first sentence, so let's take note and dissect it properly. So first thing it says John has a mass of 70 kg, so this is the mass. He's able to complete 2.4 km run, so this is the distance or the length. Okay, do take note that this is in km, okay? And the run is in 12 minutes, so this is the time, but do take note it is in minutes by exerting an average force of 65 Newton. So this is the force. Now, they say calculate the work done by John to complete his 2.4 km run. So we need to find work done. Okay, work done. Let's try get rid of this. Okay, so work done, we know is equal to force times distance. Force is given here. Distance we have is 2.4 km. Now, do take note the distance needs to be in meters. So this will actually be 65 multiplied by 2.4 km. So it's 22.4 multiplied by 1,000. Okay, to convert meters into km. So if you take 65 multiply by 2,400, what you're going to get is 156,000 joules. Okay, so 156,000 joules. That's the work done. Now the answer calculate is running power. So we need to calculate power. So we know power is equals to energy divided by time. Energy we already calculated here. Work done 156,000. So this equals to 156,000 divided by time. Now, because power, the time I mentioned needs to be in terms of seconds. So this is 12 minutes. I need to convert 12 minutes to seconds. So 12 multiplied by 60. Okay, so what you're going to get is power is equals to, let's 12 times 60. I'm going to get 156,000 divided by 720. Okay, so 156,000 divided by 720. What you're going to get is 216.6 watts. So the power here, do take note, once again, 2 or 3SF is going to be 217 watts. I'm going to round it off to 3SF. They say Peter has the same mass as John, but has a higher running power than John. Using the equation, explain why Peter will complete the 2.5 km run faster. Okay, so imagine both of them, they have the same work done because if they have the same mass, we take it as the power equals to energy divided by time. We take it that they have same mass, they cover the same distance. So this should be fixed, okay, between John and Peter. Okay. Now, but in terms of then they did say here that Peter has a higher power. Peter's power is higher. Now, if my energy is fixed, but the power is higher, what do you think about the time? Okay, if the denominator is smaller, I will get a higher power. If my denominator is bigger, I'll get a lower power. So in this case here for Peter, if his power is higher, that means the time taken for him to complete the 2.4, it must be smaller. So how to explain? So as the energy needed to complete the race, for John and Peter is the same. But the power for Peter is higher. So therefore, using P equals to E over T, Peter would have a lesser time or / use lesser time to complete the 2.4. Okay, so that's for question 2.